This is the Lesson 6 activity for college algebra. Okay, we're going to start with a break-even analysis. Many applications in various disciplines involve finding the point of intersection of two graphs, or the solution to a system of linear equations. A common application where we see this in business is called a break-even analysis. So here's some vocabulary. Suppose a company produces and sells X units of a product. Fixed cost is the initial investment to get the business up and running. It does not depend on how many units they produce or sell. It just is. Okay, so it's just an amount that you're going to have to pay no matter whether your business fails and you make and sell nothing or thrives and you make and sell millions. Okay. Your cost function is a formula for total costs. So we call it C of X, and it's fixed cost plus cost per unit produced times the number of units produced. So cost is going to be fixed cost plus your cost per unit times your number of units. Revenue is the total amount of money coming into the business. So it's the number of units sold times the price per unit. And profit is revenue minus cost. And a company breaks even when revenue equals cost, or profit is 0. So for example, to launch a new product, it is often requires a substantial investment. So a company has to sell enough units so that total revenue offsets the total cost. When this occurs, we say that the sale of the product has reached the break-even point. Work through the following example and apply your knowledge of linear systems to do a break-even analysis. Technology is now promising to bring light, fast, and beautiful wheelchairs to millions of wheelchair users. A company is planning to manufacture these radically different wheelchairs. Fixed cost is $500,000. We can also think of this as startup costs. And it will cost $400 to produce each wheelchair. Each wheelchair will be sold for $600. So we'll work through the steps to find how many wheelchairs must be produced and sold to break even. So we define our variable expressions. X is going to be the number of wheelchairs produced and sold. The answer to the question, right? Typically, how many wheelchairs, the question, we define a variable that is the answer to the question. So number of wheelchairs produced and sold. 400x, that is the cost to produce the wheelchairs. Cost to produce X wheelchairs. And 600x is revenue. Okay, because the price per wheelchair times the number of wheelchairs, revenue. So our total cost is our fixed cost, $500,000, plus 400x. And our total revenue is 600x. And now we want to write and solve an equation to find the break-even point. So when does cost equal revenue? That's the definition of break-even. So we set 500,000 plus 400x equal to 600x and solve for x. We get 2,500 wheelchairs. So the answer to the question, which was how many wheelchairs must be produced and sold to break even, is 2,500 wheelchairs. So 2,500 wheelchairs produced and sold is the break-even amount. Okay, I kind of just wrote the answer down for this one down in the previous question, but I'll write it again. Describe what the break-even point means in the context of this problem. So it means that when 2,500 wheelchairs are produced and sold, cost and revenue are the same. Cost equals revenue. So the graph below is a picture of the example above. We want to fill in the boxes on the graph with appropriate cost and revenue equations. So let's see, the blue line represents cost, okay? Because from 0 to 2,500 wheelchairs, we're operating at a loss, okay? Our costs are greater than our revenue, okay? So the blue line is revenue, and that was 600x. And the red line is cost, which was 500,000 plus 400x. Cost, revenue. And then you see that for the first 2,500 wheelchairs, like money is coming in, we have revenue, but it is not, but our costs are greater. So this shaded area represents losses. Okay, so we're losing money until we hit 2,500 wheelchairs, and then we start to have some profits. Okay, and at this point, we knew the 2,500, we solved for that. The 1.5 million, that's the y coordinate here, that's our cost / revenue. Okay, so when costs and revenue are the same, I could actually say, instead of just saying that they're the same, we could say are both $1.5 million. Okay, we spent 1.5 million and we have brought in 1.5 million, so we've broken even. Okay, so what happens for x's between 0 and 2,500? We have loss. And when x is bigger than 2,500, we have profit. Okay, because our revenue line is greater than our cost line. Okay, next problem. In 2000, the combined population of Minneapolis and St. Paul was 670,000 people. The population of Minneapolis was 96,000 greater than the population of St. Paul. And they did not ask a question. I'm going to assume they want to know what are the populations of Minneapolis and St. Paul. Are the populations of Minneapolis and St. Paul. So if we identify variables, we'll let x be the population of Minneapolis, and we'll let y be the population of St. Paul. And then we'll write down some equations. So I know the combined populations, when I add them together, x plus y should give me 670,000 people. And I know that the population of Minneapolis is 96,000 greater than the population of St. Paul. So to get the Minneapolis population, which is x, I have to add 96,000 to the population of St. Paul, which is y. And then I can solve this system of equations. I'm going to use substitution because I already have x solved for. So I'm going to take this 96,000 plus y and put it here for x. So I have 96,000 plus y equals 670,000. So 670,000 minus 96,000 is 574,000. That's 2y. So y is, divide that by 287,000. So that's our population of St. Paul. And then the population of Minneapolis would be add 96,000 to that. 383,000. Number 3, a hotel has 200 rooms. Those with kitchens are $100 per night, and those without kitchens are $80 per night. So on a night when the hotel was completely occupied, revenues were $17,000. How many of each type of room does the hotel have? So there's our question. How many of each of the two types of rooms? So we'll let x be number of kitchen rooms, and y be the number of regular rooms, non-kitchen rooms. So my system of equations is I need two equations because I've used two unknowns here. We know the hotel has a total of 200 rooms. So if I add the kitchen rooms and the non-kitchen rooms, I should get 200. So there's one equation. And then I need a revenue equation. So the kitchen rooms rent for $100 a night. So 100 times the number of kitchen rooms. And then the non-kitchen rooms are only $80 a night, so we do 80 times the number of non-kitchen rooms, and that should give me a total revenue of $17,000. And then I can solve by substitution. Okay, so y would be 200 minus x, so 100x plus 80 times 200 minus x equals 17,000, and then we'll just solve for x. Got it. So I did the solving and I got x is 50. So that is the number of kitchen rooms. There are 50 rooms with a kitchen. I can solve for the y by plugging back in 200 minus 50 and I get 150. So there are 150 non-kitchen rooms. So my interpretation is there are 50 kitchen rooms and 150 regular rooms. Number 4, this is an optional extra practice. You can move on to the next lesson if you feel ready to do that. 1 Snickers bar and 2 Reese's peanut butter cups contain 737 calories. 2 Snickers bars and 1 Reese's cup contain 778 calories. So find the caloric content of each candy bar. So there's our question, the caloric content of each candy bar. So I'm going to let X be calories in the Snickers and Y be calories in the Reese's. So my system of equations, let's see, I have 1 Snickers bar, so that would be an X, and plus 2 Reese's, 2y, that's 737 calories. And then 2 Snickers bars, so 2 X's, and 1 Reese's is 778 calories. So I've got 2 equations with 2 unknowns. I can solve by substitution. So X would be 737 minus 2y. Plug that into the other equation for the X. 2 times 737 minus 2y plus y equals 778. I get 1474 minus 4y plus y equals 778. We combine like terms, subtract 1474 from both sides, and I get negative 696. Divide by negative 3. And I get 232. So that is the calories in a Reese's, because I had let Y be the Reese's calories. So my interpretation is I can start that. Reese's have 232 calories. And I also need to know Snickers. So Snickers have how many? So that's my X. So I can go back up here and say, well, X is 737 minus 2 times Y, which I now know is 232. $273. Number 5, an additional extra practice problem. A company that manufactures bicycles has a fixed cost of $100,000 and it costs an additional $100 to produce each bicycle. The selling price is $300 per bike. So we want X to represent the number of bicycles produced and sold, and we're going to determine the break-even point. So cost is going to be $100,000, our fixed cost, plus $100 per bicycle. And our revenue is $300 for every bicycle, so 300 times X. The break-even point, I should have said revenue equals, is when cost equals revenue. So when 100,000 plus 100X equals 300X, and we have 100,000 equals 200X. So X is 100,000 divided by 200, and we get 500. So 500 bicycles lead to breaking even. To break even, the company must sell 500 bicycles. What is the cost and the revenue at that point? The revenue would be 300 times 500, 300x. So 300 times 500 is 150,000. And we'll see cost should be the same if we did this right. So it's 100,000 plus 100 times 500, and that is 150,000. So that's what makes this a break-even point. It means the amount of money that's coming into your business and the amount of money you've spent are equal. Okay, so our break-even point is 500 bicycles.